In this codecast, I'm going to introduce pointers, a very fundamental notion in C programming. To do that, I'm going to activate the memory visualization of codecast. So that's a very simple line here that is only available on codecast and will activate the visualization of the memory. And I will create a program with 3 variables, and we will try to get the addresses of those variables and to print the addresses of those variables using pointers. First, let's create an integer, a. Let's put 42 as a value, then a double d. The value, something like 58.394. And then a character with a value R, like Remy. Let's compile and see what happens in memory if we execute step by step. As you can see, we have a view down here that you can drag and scroll. And if we execute step by step, we see that first the variable A takes 4 bytes, then D 8 bytes, and C 1 byte. And then we see some addresses, and we will try to get the addresses of those 3 variables and put those addresses into variables that are called pointers. Let's do that now. First, I will get the address of the variable A. For that, I need a variable that will get the address. And the type of this variable is int star. Int star means that the variable will get an address, and at this address, you will have an integer. Let's call it address of A. And how do I get the address of A? Well, we'll use the special character ampersand, like this. And we put the name of the variable of which we want the address, A. And that's it. Like this, it means get the address of A and put it in the variable address of A. The type of this variable is int star. It means a pointer to an integer. It means it's an address, and at this address, there is an integer. Then I'm going to show you how to print this address. So let's do a printf that says address of A is. How do I print an address? We use the special formatter %p. P means pointer. It's a synonym of a variable that contains an address, a pointer. All right, \n, and here I put address of A. Let's do the same for the double. So double star, and then address of D. How do I get the address? Ampersand. What's the name of the variable? D. Let's do the same printf. Address of D, %p, \n, address of D. And let's do the same for the character. Star, address of C. We get it with %c, and we printf like this, address of C, %p, \n, and we print the value of address of C. All right, looks good. Let's try to compile and execute step by step. I hit the compile button and I execute step by step. So first we create the 3 variables, and as you can see here at the bottom here, we have the activated the memory visualization with this special line here that is specific to the codecast, so that we can understand how the pointers are working. So first we have variable a that takes 4 bytes in memory, starting from FFFC up to FFFF. Then we have the double D starting at address FFF4 up to FFFB. And then we have the variable C at the address FFF3. So let's see what happens when we execute this line here to get the address of A and put it in a variable that is called address of A. So we create a variable address of A and we get the address of A. What is the address of A? Well, it's the one that is at the beginning of A, meaning FFFC. And indeed, inside of the variable address of A, we have the value 0xFFFC, meaning that the notation is hexadecimal, 0x, and then the address is FFFC. All right, we will print, and inside the terminal, we see that address of A is FFFC, this time without 0x. The same will occur for the double. So we have address of D, and the variable takes the value FFF4, or within the memory visualization, 0xFFF4. And indeed, it's the beginning of the variable D, starting from address FFF4 to FFFB. So we take the beginning, FFF4, and we put it in address of D. We print it the same way, and we do the same for address of C. Indeed, address of C is FFF3, and we print it like this. So, as you can see here in the memory visualization, addresses are always 4 bytes long. This is right for 32-bit systems, but sometimes you have 64-bit systems. 4 bytes are indeed 32 bits. So that means that codecast is working in 32 bits mode. If we had a 64-bit system, we would have, instead of 4 bytes for the addresses, we would have 8 bytes. That's it. So you know how to get an address from a variable, how to put it in a variable, and how to create variables that can contain addresses. These variables are called pointers. Why? Because they point to another variable. Address of A has an address that points to another variable. The same for address of D, and the same for address of C. You also know how to print a pointer with %P. Now I invite you to execute yourself this program step by step so that you understand everything that I just said. Try it yourself now.